The objective for this next lesson is 6.2. I can solve multiplication and division equations. And just like last time, we're going to start with writing out the multiplication property of equality. So the multiplication property of equality states that an equation, let's say this instead. Both sides of an equation stay equal if I multiply both sides by the same number. Let's say same value because it doesn't have to be a number. So I could have probably worded that a little bit better, but if I multiply both sides of the equation by the same number, both sides will stay equal. Same thing with the division property of equality. Division property of equality. Let's say if I multiply both sides of an equation by the same value, both sides will remain equal. And then we'll do some examples. So same idea as in the last video. If I have 6 times x equals 24, my goal is to get the variable by itself, and I need to undo what's being done to the variable. So we're going to use the inverse operations. The inverse of multiplying, so the inverse of multiplication would be division. Put inverse operations up here. So the opposite of multiplying by 6 would be dividing by 6. And whatever I do on this side, I need to do on the other side. So 6 divided by 6 is 1, so I have 1x, or just x. 24 divided by 6 is 4. And then remember to check my work. I could plug 4 back in for x. 6 times 4, does that equal 24? It does, so then we did it, and we did it correctly. Alright, for example 2, let's do y divided by 3 equals -7. The inverse of division would be multiplication. I'll put operations up here too. So we're trying to get the variable by itself. We want to undo what's being done to the variable. The opposite of dividing by 3 is multiplying by 3. When I do division equations, I usually write it a little differently. I show the multiplication to the side, and I'll show you why that makes more sense in a second. This is really 3 over 1. I can cross cancel here. 3 goes in here one time and in here one time, so I'm left with 1y. So it makes more sense to multiply these fractions if I just write it to the side instead of below. And then -7 times 3 is -21. I need to check my work. I would do -21 divided by 3. So I replace the y with a -21, and we're going to see, does that equal -7? A negative divided by a positive is a negative. 21 divided by 3 is 7. So it does work. That means we did that one correctly. Okay, for problem number 3, example 3, let's do -5p equals -45. I want to do the opposite of what's being done to the variable. The opposite of multiplying by -5 is dividing by -5. So if I divide by -5 on this side, I have to divide by -5 on this side. -5 divided by -5 is 1, so I have 1p equals -45 divided by -5 is +9. I'll check my work. Negative 5 times 9. Does that equal negative 45? A negative times a positive is a negative. 5 times 9 is 45. So we did that one correctly. And then we'll do one more. Sorry, my notebook keeps turning. The last one will be, let's do negative a over 7 equals 4. And when we do this one, we're going to draw our line again down the equal sign to remind us what we do on one half, we have to do on the other. The opposite of dividing by 7 is multiplying by 7, and I like to show that, remember, to the side instead of below. But I want to get rid of the negative and the 7 at the same time, so I'm going to multiply by a negative 7, because I know a negative times a negative will be a positive. So if these cross cancel, and a negative times a negative is a positive, this will give me a positive a, which is what I want. 4 times negative 7 is negative 28. And I'll check my work and plug it back in. So I had a negative here, a negative 28, and a 7 on the bottom. I'm going to simplify this part first. Negative 28 over 7 is negative 4. The opposite of negative 4 is a positive 4, which is what I wanted to get on the other side. So we did that one correctly as well.